Okay, I've got a router on a stick topology here I'm going to do in Packet Tracer. So what I'm going to do is I'm going to create sub-interfaces on this interface on the router for each VLAN. And at the end of it, after I configure everything, each VLAN will be able to communicate with each other. So VLAN 10 will be able to communicate with VLAN 20, VLAN 30, VLAN 40, VLAN 50, for example, and vice versa. These VLANs will be able to communicate with VLAN 10 and the rest of the VLANs within this topology. A VLAN is a virtual local area network, and basically the reason why we would set up VLANs is because for example, if we have a bunch of computers, say in a company, so we've got engineering department, and we don't want engineering department to be able to communicate with the sales department, then we would create a VLAN for all the computers in the engineering department. So for example, we'd put all the engineering department computers in VLAN 10, and we don't want them to communicate with the sales VLAN, the sales computers at the company in VLAN, and we put them in VLAN 50, for example. And another thing is, without the VLANs, for example, in this topology, this would be one broadcast domain. This whole topology here would be one broadcast domain, and that's bad because like one broadcast domain is using up a lot of resources. All the broadcasts have been flooded through this one whole domain, and it can cause, like with a lot of computers on the network and in devices, and like if the network's really big and it's growing bigger and there's only one broadcast domain, users are going to experience slowness on the network, because it's a lot of resources are being used. And if we put different VLANs, if we put different, like say engineering department, sales department, finance department, if we split them all up in different VLANs, then they're not going to be using one broadcast domain. So every VLAN is going to be a separate broadcast domain. So that makes it a lot better as well. So we're not using just one broadcast domain, we're using several broadcast domains, because every VLAN is going to be a separate broadcast domain. So that makes it better, because then broadcasts aren't going to be flooded in the network where they don't need to be flooded. And another good thing about VLANs is it's good for security as well, because if, for example, a device in one VLAN is compromised, it's not going to be able to easily propagate the network and access other devices on the network because it's in a VLAN. So that's another good thing as well, unless somehow the attacker learns how to do VLAN hopping, which is by sending a double tag like 802.1q tag to be able to try and VLAN hop. So I'm going to start setting up the router on a stick topology here. I'm going to start at the switch. Just going to give the switch a name, so I'm just going to go SW1 switch 1, so host name, to change that. Go into interface F01, switchport mode access. So I'm going to make this a static access port, and switchport access VLAN 10. So what that's going to do is it's going to make the fast Ethernet 01 port and access for VLAN 10, so only VLAN 10 traffic will traverse through that port, so no other VLAN traffic will go through that port. So that's just so that only the devices within that port for VLAN 10. Now you can create the VLAN manually, or when you put this command in, the switch will create the VLAN automatically. So I'm going to create the rest of the VLANs manually now. So VLAN 20, VLAN 30, VLAN 40, VLAN 50. We can give the VLANs names, for example, like to go VLAN 10, engineering, VLAN 20, PCs, 30, sales, 40, finance, 50, let's do support, that'll do. Mode access, make it access, static access port, access VLAN 20, three, 4, 5, access VLAN 30, Okay, so we've made all these ports permanent static access ports, and we've put them as access VLANs ports in the appropriate VLAN. So we've made this a access VLAN 10, access VLAN 20, access VLAN 30, access VLAN 40, and access VLAN 50. So that's good. We're just going to verify now. So show VLAN brief. And as we can see here, engineering's, PCs, sales, finance, support, they're the names we made the VLANs. They're active, and these are the ports that are in each VLAN. So that's all correct. Now we're going to set up a trunk. We need a trunk between the switch and the router. So at the moment, if we go show interface trunk, we're not going to have any trunk link active. As you can see there, we don't. So we're going to have to set up a trunk. 001. Set it up as a trunk first, because we're using the native VLAN 1 at the moment, which is bad security practice. So during this lab I'm going to change the native VLAN to another VLAN that's not the native VLAN 1. So I'm not going to use VLAN 1 as the native VLAN in this topology. So switchport mode trunk, that'll make that interface a trunk, so the port will be a trunk port. Now I'm going to go on to I'm going to save this, running config startup config, and I'm going to go to the router now and configure the router. We need to make a sub interface for each VLAN, and in order to do that we need to, so this interface is gig 00, so we're going to start making the sub interfaces and configuring the sub interfaces. So in order to make that, I'm going to go interface gig 00.10 for VLAN 10, and that's going to create the sub interface of G00.10, which is going to be used by VLAN 10. So I need to enable encapsulation. So encapsulation.1q and then the VLAN, which is 10. That's going to enable encapsulation.1q for that VLAN. Because when the traffic passes over the trunk, the traffic needs to be encapsulated, and it's going to be encapsulated in .1q and tagged for that specific VLAN, so it knows where to send the traffic. So like it'll add a 4-byte tag, and then that'll know, okay, this has got to go to VLAN 10, and then it'll send it to VLAN 10. Whereas like native VLAN traffic is not going to be tagged, it's going to be untagged. It doesn't get tagged. So for example, right now we're using the native VLAN 1, so the traffic for VLAN 1 is not going to be tagged, but the traffic for VLAN 10, 20, 30, 40, 50, that's going to be tagged. So otherwise, if it's not tagged, it's going to assume that the traffic's the native VLAN traffic and it's for VLAN 1. And if it's tagged for VLAN 20, it knows, okay, this traffic's for VLAN 20, so it needs to be sent to VLAN on VLAN 20. I'm going to add an IP address, and 192.168.1.1 we're going to make. It's a /24 subnet mask, so 255.255.0. And I'm going to go and show this brief, and we're going to make it up, so no shutdown. Now, all the sub interfaces will not come up until I enable the interface gigabit 00. So until I enable that interface, all the sub interfaces will not come up. So, but I'll enable that at the end after I've configured all the sub interfaces. So I'm going to make the sub interface for VLAN 20 now. Encapsulation.1q20, and I'm going to add an IP address on it now. 32.16.1, and this is a /28 subnet mask, so there's only going to be 14 usable addresses. So we're just going to make that .1, and it's 240 for a /28. Shut down. Sub interface for VLAN 30 now. Encapsulation.1q30. IP address 154.12.1. This is a /27. So it's going to be 30 usable hosts. Which is the subnet mask for a /27. And no shutdown. Off to do the sub interface for VLAN 40 now. And the encapsulation.1q40 because it's for VLAN 40. And IP address 1.1, it's a /25, so there'll be 126 usable addresses. 128 is the subnet mask for a /25. Shutdown. And now we'll do the last sub interface for VLAN 50. Encapsulation.1q50. IP address. 1. It's a /24 subnet mask, so 255.255.250. There's two ways you can do for the native VLAN. So I could just add an IP address on this interface and this interface, and then just keep it in VLAN 1, for example, and it would still work. Like towards the end, all the VLANs would still be able to communicate with each other. Or I could create a sub interface for the native VLAN on the router, and I'm going to do that in this topology because I'm going to change the native VLAN from VLAN 1 to another VLAN for best security practices. So, and I'm just going to make the native VLAN 60. So first I'll do, okay, so this is going to be the subnet for the native VLAN. Let's do a /30. And that's going to be the subnet I'm going to use for the native VLAN. So IP address 192.1.252, which is the subnet mask for a /30. Oh, my bad. I forgot to do the encapsulation first. So encapsulation.1q60. Now this will work. And oops. Actually, I have to add the native word at the end of that to make it the native VLAN. So this is going to be the native VLAN sub interface. So encapsulation.1q60 native. Now I'm going to add the IP address, and now I'm going to issue the no shutdown, and that's going to be the sub interface for the native VLAN. I'm going to bring up the interface, the actual physical interface of router 1, which is interface G00, no shutdown, and as you can see there, when I bring up that interface, all the sub interfaces come up at the same time as well. Now I'm going to verify that, show IP interface brief, and as you can see here, I have all these interfaces in an up state. So you've got the sub interfaces I've created, the IP addresses I configured on them, and they're in an up state, and G00 is in an up state. There's no IP address assigned to this interface because I created the sub interface of G00.60. That's going to be for the native VLAN. As I said earlier, you can do it this way, or you can put an IP address on the physical interface of G00. So there's two ways of doing it. Show VLANs. There we go, show VLAN. This is going to verify okay, nothing's there yet. Alright, so we're going to go back on the switch. I'm going to set up the native VLAN on the switch now. So G01 switchport trunk native VLAN. Actually, I'll create the VLAN first, VLAN 60, and then switchport create the native VLAN to be VLAN 60. So now the native VLAN is 60. Just to verify, do show VLAN. Just do show interface. And as you can see here, the native VLAN is now 60. VLAN 60, which has been created. Save the configuration. We'll save the configuration now. Something showing up there. Save the configuration on router 1 as well. Now I need to, there's two ways. I can set up a DHCP pool for each VLAN, or I could set the IP addresses statically. But I'm going to set up a DHCP pool for each VLAN in this topology, so I have to set up a pool for each VLAN on router 1. I'll make that the DHCP server, because the devices in the VLANs are going to need IP addresses. Once I've set IP addresses on them and they have their subnet masks and default gateways configured, they'll be able to communicate with each other. So with router on a stick, the VLANs will be able to communicate with each other. And I know I said earlier that, you know, a good thing about VLANs was devices in a VLAN can't communicate with other devices in the VLAN, like in another VLAN. But in the router on a stick configuration, what that does is basically devices in one VLAN will be able to communicate with devices in another VLAN, because each VLAN is in a different subnet. It needs a default gateway and it needs a router to be able to route the traffic to another VLAN. Like if you want to communicate, say for example, you have a device in VLAN 10, you want to communicate with another device in VLAN 40. Well, if you don't have a router, you're not going to be able to do that. The switch can't route traffic from one subnet, one IP address, one subnet to another subnet. You need a router for that. Whereas, for example, devices on the same subnet, they don't need a default gateway. The switch will just switch, and then you'll be able to communicate directly with another device on the same subnet. You don't need a router. The traffic doesn't need to be routed. But if you want to communicate with a device on another subnet, you need a router. Like the router needs to route the traffic to that other subnet. And that's why we need to use a default gateway as well when we need traffic to reach another subnet, whether it be in the same network or another network somewhere out there on the internet. We need to route the traffic, so the traffic needs to go to the default gateway to the router, and the router will route the traffic to that subnet on wherever that other subnet's sitting, somewhere else on the internet, somewhere else on the same network. I'm going to set up DHCP pools now. So IP DHCP pool, and we're just going to name it VLAN 10. So that's going to be the pool. So we're going to set up the pool for network 192.168.1.0, 255.255.255.0. So I've set up the DHCP pool VLAN 10 for that network, which is the network in VLAN 10. And default router, which is the gateway. So the gateway is going to be 192.168.1.1 because that's the IP address we set up on the sub interface of G00.10. That's going to be VLAN 10's default gateway. So default router being the same thing, default gateway. So that's going to be that address. And we're going to leave everything else. We're just going to set up the network and the default router. Another thing is we can set up so we don't use the 192.168.1.1 address as a usable, leasable address. So because we're using that address for the sub interface of G00.10, we don't want the DHCP server to actually lease that address to a client. in VLAN 10. So I'm going to exclude that address. IP DHCP excluded address 192.168.1.1, and that's going to exclude that address so that the DHCP server doesn't use that address to lease to a client in VLAN 10. DHCP excluded address. So we're going to exclude the addresses used for the sub interfaces in each VLAN. Actually, I'm going to exclude 1.1 to 192.168.1.2. Exclude the addresses from that from 172.16.1.1 to 172.16.1.2 in that subnet. So now I'm going to set up a DHCP pool for VLAN 20. VLAN 20, and the network 172.16, and it's a /28, so 240. And I'm going to set up the gateway 172.16, and that sets up the gateway for VLAN 20. VLAN 30 now. Let's say /27, so that's the subnet mask for a /27. I'm going to set up the gateway now. 54.12.1. VLAN 40 now, and network 32.1.0, and it's a /25, so that would be 28. That's a subnet mask for a /25. Set up the default gateway now, default router 1. /24 subnet mask, and set up default gateway now 24.10.1, and I'm going to verify all this, so show running config, and I've excluded the addresses here, and as you can see IP the VLAN 10 network and the default router. So you can see the configurations I've done on each VLAN DHCP pool. And the configurations that I did on the sub interfaces here in the running config. Okay, so now I'm going to turn DHCP on. and as you can see here, the DHCP request was successful. So with DHCP, what happens is the devices in that VLAN, they're not going to have an IP address initially. It'll start as 0.0.0.0. And what happens is the device will send a discover message out to reach a DHCP server, and it sends it to a broadcast address of 255.255.255.255. And basically, when the DHCP server gets that discover message, it'll send an offer message back to the client that sent the discover message, and I'll say, okay, I have this IP address, I'm offering this IP address. And basically what's happened is the DHCP server has offered the IP address of 192.168.1.3, and that offer message has been sent. The client's received that, and then the client's like, okay, cool, I'm going to take that IP address, and then it's going to send a request message back to the DHCP server saying, okay, I'm requesting the IP address of 192.168.1.3, which is the IP address you offered me. And then the DHCP server is going to receive that request and going to say, okay, cool, you want the IP address of 192.168.1.3. Then the DHCP server is going to send an acknowledgement back to the client, and that acknowledgement packet's going to send back the IP address of 192.168.1.3. When the client receives that acknowledgement, then the client's going to use the IP address of 192.168.1.3. And the default lease for a DHCP address is 1 day. You can change the lease to whatever you like. You could lease an address for 1 hour, 2 hours, 5 hours, 7 hours. You can change that, the lease, in the DHCP configuration. So it's sent out the IP address, the subnet mask, and the default gateway. So if I ping the default gateway now, it should be able to successfully ping it, and it can. So this PC in VLAN 10 can successfully ping the default gateway, which is good. I'm just going to enable DHCP on the other PCs in the other VLANs. So enable DHCP on the PC in VLAN 20, and that's been successful, as you can see here. And the reason why we use DHCP is the DHCP server is giving dynamic IP addresses to the hosts that request them. This just makes it a lot easier, so it's not an administrative burden for an admin, because if we didn't use DHCP, we'd have to go to every single PC within the network and configure a static IP address on every single computer and device within the network, subnet mask, default gateway, DNS server. We'd have to configure all that manually, and if you're administrating a network of thousands of users, you can see that that's going to be a major pain in the butt, right? If you have to go around and statically configure an IP address, subnet mask, default gateway, and the DNS server on every single device, thousands of devices, it's going to take a long time, right? So that's why DHCP, a DHCP, is used for that reason, to ease that burden. So we could just set up DHCP pools on the DHCP server, and that could be a router, it could be a physical server. You could set up a wireless access point as a DHCP server, So it just eases that burden. It makes it so much easier and nicer to use DHCP than have to statically configure every device. So that was successful. So now the computer in VLAN 30 has an IP address, subnet mask, and a default gateway. I haven't set up a DNS server in this network, so we're going to ignore the DNS in this topology. And that request was successful. Great. So each PC and each VLAN now has an IP address, a subnet mask, and a default gateway. So let's start by pinging the default gateways of each VLAN. So make sure that's working. And the PC in VLAN 50 can successfully ping its default gateway, which is great. PC in VLAN 40 can ping the default gateway successfully. Let's try the PC in VLAN 30. And we're getting successful replies from the default gateway. Successful as well from the PC in VLAN 20. And we've already tested the PC in VLAN 10 that can successfully ping its default gateway. So now we're going to test to see if we can ping from each VLAN to the other VLAN. So I'm going to try ping from VLAN 10 to VLAN 20, VLAN 30, VLAN 40, and VLAN 50. So I'm just going to see what the IP address was. Okay, so 172.16.1.3. So I'm going to try ping this PC in VLAN 20. That's successful. We can successfully ping from VLAN 10 to VLAN 20. And that's successful as well. We can ping from VLAN 10 to VLAN 30. Successful. We can ping to VLAN 40. And we can also ping to VLAN 50. We can try to ping from some of the other VLANs now to some of the other VLANs. So I'm going to try ping VLAN 10 from VLAN 30. And that's successful. VLAN 50, and that's successful as well. VLAN 40, and as you can see here, we're able to successfully communicate with the other VLANs from other VLANs within the network. Just pinged VLAN 40, try ping VLAN 10. And as you can see, it's all working. All the VLANs will be able to ping each other VLANs. So That's verified that we have set up the router on a stick correctly. Now we won't be able to ping. I'll set up a IP address on the switch. So interface VLAN 60. It's the management VLAN. I'm going to set up the IP address of 192.168.2.2/30 subnet. So that's the subnet mask for a /30. Just to verify that, and that IP address has successfully been configured on VLAN 60. Now I shouldn't be able to ping that IP address from the PC yet. It's not going to work. I need to set up a default gateway on the switch. So I'm going to set up the default gateway on the switch. So configure terminal, default gateway 192.168.2.1, which is the IP address of the subinterface of G00.60 on router 1 here. And so I'm going to try and ping from the switch. And that's successful. So the switch can successfully ping router 1 at 192.168.1.1. Now I'm going to try ping the switch again from the PC. And now, as you can see, I can successfully ping the IP address of the switch, which is on VLAN 60, which is the native VLAN we used for this topology. And I should be able to ping from any PC now to that IP address. So if you don't set up a default gateway from the switch going to the router, the PCs won't be able to ping that IP address that's configured on the switch. And as you can see here, I can successfully ping it from VLAN 40 also, the PC in VLAN 40. And I can successfully ping switch 1's IP address, management IP address from the PC in VLAN 50. Now if we wanted to, I'm not going to do it in this topology today, but if we wanted, for example, to stop VLAN 10 from communicating with VLAN 50, because we're using a router on a stick configuration, then we could set up access lists. So we could set up an access control list, so VLAN 10 can't communicate with VLAN 50, for example. So that fixes the problem, because I mentioned, you know, when you set up router on a stick, the PCs will be able to communicate with each other, yes. So if you wanted to set up a router on a stick and you wanted, you know, for example, as I said, VLAN 10 to not communicate with VLAN 50, you can still achieve that by setting up a access control list, and then the PCs in VLAN 10 will not be able to communicate with the PCs in VLAN 50. Or if you wanted just a certain host in VLAN 10 to not communicate with a certain host in VLAN 50, you could set it up so only that host can't communicate with that other specific host in VLAN 50 by an access control list as well. Or if you wanted, for example, like a certain device in VLAN 10 to not be able to use the protocol ICMP to communicate with a device in VLAN 50, then you can set that up as well. Or you don't want it to communicate on a certain port, then you can set that up in an access list as well. But you would need to use an extended access list for that. You couldn't use just a standard access list to achieve that though, because excuse me, a standard access list you can only use source address only, whereas with a extended access list you can use source, destination, protocol, port number. So there's a lot more flexibility in a extended access list. Standard access list doesn't have much flexibility. It's best practice to shut down all the ports that aren't being used, so I'm going to do that. So I'm going to show VLAN brief. Now, as you can see here, the ports F06 to F024 and the Gig02 ports are not being used, so I'm going to shut them down. So a good way to do that is conft interface int range for interface range, then F06 to 24, then I'm going to do the Gig02 port, and I'm going to put a name, so I'm just going to go unused ports. Description, unused ports, and now I'm going to shut them down. So to verify that I've shut them down, as you can see there, I've shut all those ports down. Even better practice actually is let's put those ports in a black hole VLAN. So create VLAN 99. Let's say name black hole, and go int range F06 to 24, 02, and I'm going to make them static access ports, and I'm going to put them in our new black hole VLAN 99. So switchport access VLAN 99, and that will put them in that VLAN now. Show VLAN brief to verify, and as you can see here, all those ports, unused ports, are now in VLAN 99. So that's just for good security practices, in case like anyone tries to plug like any device in into those ports, then those ports are shut down, so no one's going to be able to use those ports unless an administrator goes on the switch and issues a no shut on those ports. And they've also been put in their own separate VLAN, which means that obviously they won't be able to communicate with these other VLANs, because I haven't set up a sub interface for VLAN 99. So none of these, even if any of these ports are not shut down, then there's no sub interface configured on the router for this VLAN. So this VLAN won't be able to communicate with any other VLANs, like VLAN 10, 20, 30, 40, 50, and so on. Another good practice as well is showing face trunk. By default we've got VLANs 1 to 1005 are allowed on the trunk link. I'm going to change that because I only want the VLANs 10, 20, 30, 40, 50 and the native VLAN 60 to be allowed on this trunk. So I'm going to change that. T-G01 interface G01 switchport trunk. So at the moment that's going to not allow any VLANs on this trunk. And just to verify that, to show this trunk, and as you can see here, no VLANs are allowed on the trunk at the moment. Now I'm going to add the VLAN switchport trunk native VLAN. Sorry, trunk allowed VLAN. And as you can see here, I can add them, I can put all, which is going to allow all VLANs. I can put accept, so if I put accept, and whatever VLANs I put in the accept means that all VLANs are not going to be allowed except those VLANs. And I use none, so that means that removes all VLANs. And you can add VLANs by putting the add, and you can remove VLANs by using the remove keyword. So I'm going to add VLAN 10. Let's just do it like this then. 20, 30, 40, 50, 60. There we go. And as you can see now, the VLANs allowed on the trunk are 10, 20, 30, 40, 50, and 60. So those are these VLANs and VLAN 60 for the native VLAN. As you can see here, we're using the native VLAN 60. Interface G01 switchport. And as you can see, the administrative mode is trunk, operational mode trunk, using .1Q encapsulation, and trunking native mode VLAN 60. And we've got no voice VLANs configured. Trunking VLANs enabled, 10, 20, 30, 40, 50, and 60. So that's good. We've got no private VLANs enabled. That's good. So I'm going to save the configuration. You should still be able to ping the VLANs. And we still can ping other VLANs. I just changed what VLANs are allowed on the trunks just for best security practices. And we're finished here. That's router on a stick configuration. I hope you enjoyed it. I hope it's helpful to you. If you like the video and you want more, please like and subscribe, and thank you very much.